Okay, so here we go with our first video. Chapter 5, Section 1, Use Properties of Exponents. This is starting on page 330. How do you simplify algebraic expressions with exponents? So scientific notation is a way of writing, this is something we're going to do in this section, a way of writing very large or very small numbers in terms of a decimal number between, BTW, it's not by the way, between 1 and 10 multiplied by a power of 10. So for example, if you have 10,492, as a reminder, you put the decimal with one whole number in front and the rest of the numbers after that. And then you have to think about how many times you have to multiply by 10 to get it back to the original number, which would be 10 to the 4th or by 1,000. So you're going to move it 4 places to the right to get it back to the original number. All right, as usual, I'm going to have you do this warm-up real quick, so take a minute to do that and then come back and check your answers. Okay, so this is what you should have gotten. Negative 2 to the third. Anytime if you were to whip this on the calculator, it should give you a negative 8, but if this was a positive exponent and you didn't put it in parentheses, your calculator will also give you a negative. You have to be careful because that wouldn't be the case. Here, this is a minus. It's probably not all that clear, but it's 25 minus 81, which is negative 56. And this you should have gotten negative 180. Here, 4 times 10 to the third, if there's 4 gigabytes, then it'd be 4 times 1,000, which is 4,000 megabytes. So before we move on, I just want to do a little bit of a reminder up here. I think we did. I know we studied this, and you guys studied this in algebra. Honestly, I can't remember if we did it in Advanced Algebra 2 or not, but I'm just going to refresh your memory. So if you had to do something like this and simplify it, you remember that x to the 6 means x times x times x times x times x. That's 5 of them, 6 of them. Divided by 3 x's. And when you have something like that, you can cancel out. So cancel out, like, because x divided by x is just 1. X divided by x is just 1. X divided by x is just 1. And then you have 3 x's left on top. So that equals x to the third. Now if you look at this and look at this, there's an easier way to get here than by doing all that. All you got to do is when you are dividing exponents with the same base, dividing powers with the same base, you subtract the exponents. So this would actually be the same as x to the 6 minus 3. And then you would still get x to the third. Now, let's say that was flip-flopped. Let's say you had something like this. Okay, I'm still going to write it out just for example's sake. If I cancel out what I can cancel out, I still have 3 on the bottom. Now they don't magically become a numerator. You have to hold this fraction in the top. You have to remember that this equals 1, that equals 1, and that equals 1, so you really have a 1 on top. So this is going to be equal to 1 over x to the third. Okay, but let's look. Does the same rule apply? Yes, it does. If you do x to the 3 minus 6 and you get a negative 3, that tells you that you have remaining x's in the denominator. So that's kind of a refresher, and I know you've done that before, so hopefully you remember a little bit about that now. All right, let's go down here and look at what we're going to do here. We're going to do a lot with powers. Evaluate the expression, tell which properties of exponents you used. Well, I went ahead and wrote the properties out here, and I'm going to explain more about them in a second, but if you need the general form, you can go ahead and look at page 330 in your book, right here. And you can see that it has the general form of all of them written here as a reference for you, so you can go back and look at those if you need to, page 330. But I'm just going to talk you through them. So the first one here, we have the power of a product. You can see inside the parentheses we have a multiplication. That's where the product comes from. And since all of that is raised to an exponent, it's called the power of a product. So all you have to do here is you got to do what's inside first. That's one way to simplify it. Another way is to distribute that 3 on both of those. Now, when you have an exponent raised to an exponent, you multiply. So what you actually have here is negative 3 to the 6th times 5 to the 3rd. And if you do that on your calculator, you would end up with negative 91,125. So remember, when you have an exponent raised to an exponent, you kind of distribute that 3 onto both of these things inside here. And a power to a power is 3 times 2, which is negative 3 to the 6th. And if you'd like me to lay it out, I will, just for this instance. This is saying negative 3 squared, which is this. But they're saying you have it 3 times. So there's squared, there's another squared, and there's another squared. So we do actually have 6 negative 3's. That's kind of how we end up with that right there. Okay? Power of a power. And so I just kind of talked about that rule. We have a power raised to another exponent, so it's a power of a power. And what we do here is we multiply the exponents. So it's 4 to the 2 times 3, which is equal to 4 to the 6th, which is equal to 4,096. All right? Product of powers. So that means we're multiplying 2 powers together. So negative 8 by itself is actually the same as negative 8 to the 1st power times negative 8 to the 3rd power. When you're multiplying a power and they have the same base, all you do is add the exponents, because really this is the same thing as 1 negative 8 times 3 negative 8's. So it's the same thing as negative 8 to the 1 plus 3, which is equal to negative 8 to the 4th, because you have 4 of them all together. And when you multiply that out, you get 4,096. Okay, power of a quotient. Remember, quotient means divide. So if we have a fraction inside parentheses and it's all raised to an exponent, what you can do is what I would do is I would distribute that 3 to both the numerator and the denominator. So that means I have 2 to the 3rd over 9 to the 3rd. And when you multiply that out, you have 8 to the 7 over 29. Of course, some of you may say, can't we just whip that on the calculator? You certainly could. You put the fraction in parentheses, and then you raise it with this little caret key. Let's see if you can see that. Raise it to the 3rd power. Push enter. And I don't want it in a decimal form, so I'm going to put it into a fraction. There you go, 8 over 729. Yes, you can do that, but you definitely need to know this rule, that you've got to distribute the 3 on both of those. Okay, negative exponent and power of a quotient. So here we have something being divided, a fraction, and we have a negative exponent. Now when you have a negative exponent, all you have to do is flip the fraction. I know it's a little tricky rule, but it's kind of cool, and this is what you do. You just flip the fraction, and then you make the exponent positive. And you can then distribute that exponent onto both the numerator and the denominator, both the numerator and the denominator. So then what you have is you have 3 to the 2 times 2 over 1 to the 4 times 2, which is equal to 3 to the 4th over 1 to the 8th, which is equal to 81 when you put that on your calculator. So that's just kind of a refresher, and you have done all those things before. All right? So here, let's talk a little bit about scientific notation. You're going to use a lot of these rules into the scientific notation problems that you're going to be doing. So this says a Federal Reserve gold bar weighs 400 troy ounces. Never heard of that before, but that's okay. What is the weight of 250,000 of the gold bars? I want you to use scientific notation. So we have to write this in scientific notation and this in scientific notation. So we take this number and we write it with one whole number in front of the decimal. You don't have to write the zeros, but I will, just for example's sake. Or you could write it just as a 4. And then I would have to move it 2 places to the right, so it would be times 210 squared Well, 4 times 10 squared. And then I have to write this as scientific notation, so I'm going to put the decimal with one whole number in front of it. And remember, I'm multiplying this times this, okay, to find the total weight. So times 2.5. If I put the decimal here, I got to move it 1, 2, 3, 4, 5 places to the right, so it's going to be times 10 to the 5th. And the easiest way to do this is remember that multiplication is commutative, so you do 4 times 2.5 times 10 squared times 10 to the 5th. 4 times 2.5 is equal to 10 times 10 to the 7, because when I'm multiplying powers with the same base, I add the exponents. I have a 1 here, 110 times 10 to the 7th is equal to 10 to the 8th. And that's my answer. Troy ounces. Alrighty. Let's have some fun. Okay, so maybe we're not setting the world on fire, but it is still kind of fun. All right, simplify the expression. So, remember when we have a product of a power, and we have all these being multiplied together, all we have to do is add the exponents together. So it's going to be the same base, W, to the 5 plus negative 8 plus 6, which will actually equal negative 3 plus 6 is positive 3. So it simplifies to W to the 3rd. Okay, now let's take a look. We have a negative exponent, so that means I got to flip the powers, the fraction, or I can distribute that exponent first. Let's see what happens. Let's try that, because this is a power of a quotient. So I'm going to distribute that exponent, which means I have C to the negative 2 divided by D to the positive 8. Anytime you have a negative exponent, you have to put it in the opposite position. So for example, this is in the numerator. It's a negative exponent. And when you're simplifying, you cannot have a negative exponent in your answer. So you're going to hold this place in the numerator with 1. You're going to keep D to the 8th where it is, because there's nothing you can do with that. But you're going to bring down C to the negative 2 and make it positive. All right? Anything with negative exponents switches places and it becomes positive. Alrighty, so here, let's look at what I'm going to do first. Do this first. So I have a negative 3 here, which means I'm going to bring it down to the bottom first. I'm going to keep the b squared in the numerator. I have a to the 3rd, I brought that down, times a to the 5th. And so that's going to become b squared over a to the 8th. Because they have the same base and they're being multiplied together, I add them. Which it makes sense. You have 3 a's here and 5 a's here, all being multiplied together. So it's a to the 8. All right, now they get really fun. So here, probably what I would do first is distribute that 3. Now you have to look at it as a numerator and a denominator. And you have to realize if this was by itself, you would distribute the 3 to everything on there. And also this, you would distribute the 3 to absolutely everything on the bottom as well. So it's going to get a little bit messy, but we can do it. So I'm going to do the 3a squared to the 3rd, which would be a to the 6th, b to the negative 1 raised to the 3rd, which would be b to the negative 3, and I'll take care of that negative in a second. Then you've got to take that 3 and raise it to everything in the denominator as well. So I have 2 to the 3rd, a to the 9th, and b to the 6th. Now let's see what I have, and I'm going to make it pretty now. Okay, So there's a couple things I can do. I see that, let's start with the a's. I have 6 a's in the numerator and 9 a's in the denominator. If I were to write them all out like I did on the front page, and I would eliminate them all, I would have 3 left on the bottom. If I crossed off all the a's I could, I would still have 3 left on the bottom, which makes sense because 6 minus 9 is -3. If you have a negative, they go on the bottom, and you can just tell by looking. So I know I'm going to take care of this right now, and I have 3 a's still on the bottom. I can do 2 to the third. That's not a negative exponent, so it's going to stay right on the bottom. And then I have -3. B to the -3 minus 6 gives me b to the -9. If when you do the subtraction, it turns out to be negative, you just put it on the bottom and make it positive. And this is a 1. Okay, so there's your answer. All right, here. We really just have multiplication going on straight across. When we multiply straight across, sometimes it's easier to put the common bases next to each other. You don't have to do this step. So you have 7, and then since you're multiplying with the same base, it's 2 plus -4. So I did that already. And then multiplying with the same base, it's 5 plus -1, which would be z to the +4. But when I simplify, I cannot have a negative. So all I have to do is take this and put it down in the bottom. Make a fraction out of it. Okay, let's do this last one. Again, this is a lot like this one. We've got to distribute that 3 onto everything. So it's going to be x to the 12th, y to the -6, over x to the 9th, y to the 18th. Now let's look and see what we can do. 12 minus 9 gives me 3 left over on top here. So it's going to be x to the 3rd in the numerator. -6 minus 18 is -24. Since it's negative, you got to keep it down on the bottom. Make it positive. Okay? All right, let's do one more scientific notation problem. The radius of Jupiter is about 11 times greater than the radius of Earth. How many times as great as the Earth's volume is Jupiter's volume? Okay, so what they're saying here is how many times bigger than the Earth's volume is Jupiter. So you have to divide the 2 volumes. I had to look up the volume of a sphere. I didn't remember for sure. I thought this is what it was. And it's in the back of your book. You have all these resource pages. So I'm going to start by representing the volume of Jupiter in the numerator. 4/3 pi r cubed. I'm going to write here, but it says that the radius of Jupiter is 11 times bigger than the radius of Earth. So I'm going to stick an 11 right in there. All right. Then the volume of the Earth I can just represent as this. I know I don't know the radii, but that's okay because stuff's going to cancel out. It's going to be real pretty here. So I wrote this wrong. I'm sorry. This has got to be outside here because it's 11 times the radius, not 11 times the radius cubed. And then all of that is cubed for the Jupiter's radius. All right, so here we got to cancel this out. Cancel this out, and then let's see what we have left. We have 11. I'm going to distribute that 3 onto both of these things inside here. 11 cubed times r cubed divided by r cubed. Oh, look how pretty that is. And it just gives me an answer of 11 cubed, which is 1331 times as great. Pretty nifty.